Hello everyone, welcome back. In this video, I want to talk about the empirical rule and how it relates to the standard deviation. So we can use this empirical rule when we're working with data that is distributed roughly normally or with a bell-shaped curve to its distribution. That is an assumption we are making when using the empirical rule, and under that assumption, the following statements are going to be true. And so this normally distributed data will have 68% of the data lying within one standard deviation of the mean, 95% of the data lying within two standard deviations of the mean, and 99.7% of the data lying within three standard deviations of the mean. And so here we have a nice little graph to help us kind of interpret what this empirical rule is trying to say. And so our data is distributed in a normal or bell-shaped way. And so here we have the average of either the population or the sample denoted right at the center of our data. And remember, the standard deviation is like a standardized step or distance we can start to move or deviate away from the mean. And so what's true of data distributed in this way is if we take a step that is one standard deviation away from the mean to the right or to the left, then that's going to capture 34% of the data for each of those steps. So moving one standard deviation to the right from the mean or the average will capture 34% of the data values. Moving one step to the left will capture another 34% of the data values. So going one to the left and one to the right in total, we're capturing or summarizing 2 times 34 or 68% of the data. And so then if we move out 2 standard deviations, we're capturing additional data. And this is all corresponding to the area underneath this distribution curve, but that's something you learn later in an integral calculus class. So the percentage corresponding to each standard deviation is not linear. We're not always going up by 34%, right? The amount we're going up has to be going down, otherwise we're gonna get over 100%. But that first step, our first standard deviation gives us 34%. The next standard deviation adds on 13.5%. The next standard deviation adds on approximately 2.35%. And beyond that, we have about 0.15% that we can kind of add into the mix. So theoretically, you can go out more than 3 standard deviations, but it's not realistic to really see that happening. Anything outside of 2 standard deviations is usually considered to be pretty abnormal or weird or strange, right? Because if you're outside of 2 standard deviations, then you're outside of 95% of the data, which is, starting to get in that unusual territory. But if you know the standard deviation as well as your average or your mean, then the empirical rule can help us do some quick stats. We can just take our mean or average and add a couple standard deviations to that value to create an interval of values. And then we can confidently say that 68, 95, or 99.7% of the data will lie within that interval.